Hello students, welcome to my YouTube channel. In this video lecture, we are going to solve all the questions from Oxford General Navigation and the chapter name is Mid-Course Test. So in between the book, there are two sets of questions for practice given. One is Mid-Course Test and the next question bank or questions that you will find in the end of the book named Revision Questions. So we will be solving both these chapters mid-course test chapter in which there are some 60 questions. We will solve all those questions with good elaboration. And then in next lectures, new lectures, we will solve all the revision questions given in the back of Oxford General Navigation book as well. So let's begin with today's question number one from mid-course test, which is very simple. What is the shortest distance in kilometers? Okay, so kilometers is the key word here. Between San Francisco, 38 north, 123 west, and Dubai, 25 north, 57-degree east. So they are talking about the shortest distance. Now, shortest distance uh, is always an advantage of a great circle track. Okay, so we have to find great circle distance between San Francisco and Dubai. Next very important thing, if you look closely, the addition of 123 west and 57 east, the addition of 123 west and 57 east amounts to 180 degree. That means these two locations are located on meridian and anti-meridian. Anti-meridian. When two locations are located on meridian and anti-meridian, the great circle track will pass through the nearest pole. Now over here, both locations are in the northern hemisphere. So the great circle track will pass across the northern pole. So the diagram will look like this. This is your earth. You are looking at the earth from the north pole, from the top. So this is your north pole. Next. So there is 38 degree north, 123 degree west. So let's label this diagram first. This becomes your prime meridian. This becomes your anti-meridian. So let's plot this location. San Francisco 38 north, 123 west. So 123 west will be somewhere here. 38 north, 123 west. Dubai 25 north, 57 east. So 25 north, 57 east. Now we have since they are located on meridian and anti-meridian, this is the meridian. The anti-meridian is on the other side of the earth. So now this is the great circle track joining San Francisco and Dubai. So your plane will fly from San Francisco, okay, across the North Pole, transition to the opposite side of the earth, which is Eastern Hemisphere, and then reach Dubai. So instead of following a track, a longer track of longer distance like this, or from here, it is simpler. It is more convenient and more profitable to follow a great circle track, fly across the North Pole, and then transition to the other side of the Earth and reach your destination. Okay, so now how to solve this question? How to find the distance? So for that, you will have to draw another diagram, just the northern hemisphere part of the Earth. We have North Pole here, which is 90 degree. Then we have Western Hemisphere 38 north, somewhere here. And then we have Eastern Hemisphere, in which Dubai is located. Location is 25 north. So our plane takes off from San Francisco, goes to the North Pole first, and from there it reaches its destination Dubai. So we have to find the total distance between Dubai and San Francisco. Okay, now it is equal to distance between the North Pole and this 38-degree north. So great circle distance between North Pole 90-degree and 38-degree north plus the great circle distance between North Pole and 25-degree north. So great circle distance between North Pole and 25-degree north. The great circle formula is distance between two latitudes multiplied by 60, or difference between two latitudes multiplied by 60. Now difference between 90-degree and 38-degree is how much? 90 minus 38, 52. So 52-degree multiplied by 60. Similarly here, the difference in latitudes between 90-degree north and 25-degree north is 90 minus 25, 65. So 65-degree into 60. 52 into 60 is 3120. 65 into 60 is 3900. 3900 plus 3120 is equal to 7020 nautical miles. So correct answer is 7020 nautical mile, but we want a final answer in kilometers. The 7020 nautical mile equals to 7020 into 1.85 kilometers. So into 1.85 is 12,987. Okay, 12,987, approximately 13,000. Okay, so your correct option will be option Charlie. One is Charlie. Number two now. A great circle has a northern vertex of 50-degree north, 100-degree west. The southern vertex will be what? Simple question. What you have to do is, if northern vertex is 50-degree north, the southern vertex will also be 50-degree, but the latitude will be south latitude. So southern vertex will be 50 degrees south. Okay, same value but hemisphere change, and longitude will be the sum of the longitudes should be equal to 180. Now we have here one longitude which is 100-degree west. Now the sum should be 180. The remaining part will be what? 180 minus 100, which is equal to 80 degree. Okay, so this will be southern vertex will have a longitude of 080. The hemisphere will be the opposite hemisphere, eastern hemisphere. Okay, so the correct option will be delta, 50 degrees south, 080 east. So now again, northern vertex is 50-degree north, southern vertex will be opposite of it, 50 degrees south. Longitude, if one longitude is 100-degree west, the other longitude will be 080 east. The sum of the longitudes must be equal to 180 degree, and the hemisphere will be opposite. If one is in the western hemisphere, the other location will be in the eastern hemisphere. Remember that. Next, question number 3. An nautical mile is defined as what? Now by definition, 1 nautical mile is equal to 1852 meter. So the correct option here will be option Bravo by definition. Option A is also correct. 1 nautical mile equals to 6080 feet, but that is not according to the definition. Question number 4. How much is the polar diameter of the Earth different from the equatorial diameter? Again a factual question. We know that due to the compression of the Earth, the very first chapter of Oxford General, due to the compression of the Earth, what happens? Equatorial diameter is more than polar diameter. By what value? By a value of 23 nautical miles or 43 kilometers or in statute miles. Now, 1 nautical mile equals to 1.15 statute miles. So, 23 nautical mile will be equal to how many miles? 23 into 1.15, 26.45 statute miles. So, or 26.45 statute miles. So first things first, equatorial diameter to be more than polar diameter or polar diameter less than equatorial diameter. So option Bravo is eliminated because it speaks of or it talks about polar diameter being more than equatorial diameter. So does option D. So Bravo and Delta both get eliminated. Now option A is less by 40 kilometers. Option C is less by 27 statute miles. So the correct option will be option Charlie. Option A says 40 kilometer, but actual number is 43. Option C says 27 statute miles, and the value that we have found is 26.45, approximately 27 statute miles. So it would be safer to select option Charlie. Okay, next. Question 5. The maximum difference between geodetic and geocentric latitude occurs at what latitude? So again a factual question from chapter number 1. So it happens at 45° north or 45° south latitude. Okay, so this question is often asked in exams. Remember this answer. 45 north and 45 south is the location where the maximum difference between geodetic and geocentric latitudes is bound to occur. Question 6. Required course is 045. Wind velocity is so and so. Flight level is 5000. Flight level is 55, which is 5500 feet. ISA conditions exist. Variation is given. Calibrated airspeed or indicated airspeed is given. What is the magnetic heading and ground speed? So let's plot this. This is your northerly direction, east and west. So your true course is 045 degree. Okay, course 045 true. Winds are coming from 190 southeast direction. So winds are coming from 190 at 30 knot speed. Next. Now what is magnetic heading and ground speed? Use your CH3. Go to option wind correction. Substitute the values. So true course is 045. So put 45. Wind speed is 30 knots. Wind direction is 190. And true airspeed. Now true airspeed will be what? It's given here that ISA conditions exist. So your calibrated airspeed will be equal to your true airspeed. So 120 knots, put 120 there. So now you have true heading of 053, true heading 053 true. Okay, next a ground speed of 143 knots. A ground speed of 143 knots. Now we have found heading, but with respect to true datum, true north datum. Ground speed is 143, so we are done with that. Now we have to convert this true heading into magnetic heading. We will do that using variation. Variation is 15 degree east. Now if variation is east, magnetic direction will be least, meaning magnetic direction will be less than true direction. So true direction is 053. Magnetic will be less than that by magnetic direction will be less than 053. So 53 minus 15 is 038 magnetic. So the final answer will be, what is the magnetic heading? It is 038. What is ground speed? Ground speed is 143 knots. So you will select the option which contains these two values. Simple. Next. What is the shortest distance in kilometers? Pay attention to this. Between Cairo and Durban. Now Cairo is 30 degrees 17 minutes north, 30 degree 10 minutes east. So is Durban at 30 degree 10 minutes east, meaning these two locations are situated on same longitude of 30 degree 10 minutes east, and Cairo is in the northern hemisphere, Durban is in the southern hemisphere. So that means there is equator separating them. There is equator, okay, 0 degree latitude separating northern hemisphere and southern hemisphere. Now Cairo 30 degrees 17 minutes north, and this Durban is 29 degree 48 minutes south. We have to find the shortest distance between them, indirectly great circle distance between them. Now great circle distance is equal to difference in latitude in degree multiplied by 60. Now what is the difference in latitude between these two locations? So it is equal to this 30 degree 17 minutes plus this 29 degree 48 minutes. So total will be 30 degree 17 minutes plus 29 degree 48 minutes, which is equal to 60 degree 5 minutes. 60 degree 5 minutes multiplied by 60, which is 3605. 3605 nautical miles, or multiply by 1.85, it yields answer in kilometers 6669, approximately 6670 kilometers. So this is the final answer. This is how you do it. Okay, so go with any option. Go with that option which has this value, 6670 kilometers. Next, question 8. An aircraft is at latitude 2 degree 20 minutes north. It tracks 180 direction, that is a south direction, for 685 kilometers. What is its new latitude at the end of the flight? So let's say this is your Earth. There is equator. Location is 2 degree 20 minutes north. Okay, and the distance traveled is the direction traveled is in southerly. Distance is 685. Kilometer, or 685 divided by 1.85, which is 370 nautical miles. When you fly a northerly direction or a southerly direction, you are actually flying a great circle track along a great circle track. Now, what is the great circle distance formula? Difference between two latitudes in degree multiplied by 60. Now, the difference between these latitudes is, or the distance traveled is 370 nautical miles. We know only one latitude. We do not. We have to find out the second latitude or the new latitude. So it's impossible to find the difference between them if you don't know the second latitude. So we write this d latitude as it is, multiply by 60. So d latitude equals to 370 by 60, which is equal to 6.1. So 6 degrees. Okay, approximately 6 degrees. Now, difference in latitude in degree is nothing but initial latitude plus final latitude or new destination latitude. Now, what is the difference in latitude? We have found out 6 degree. Initial latitude is 2 degree 20 minutes. We have to find the new latitude of final latitude. Now here we have used the addition sign because this aircraft flies in the southerly direction. So there is a high probability that it crosses equator and enters southern hemisphere. Therefore I have used the addition sign. If this aircraft were to fly in the northerly direction from this position, I would have used subtraction sign. Okay. So look at the question, draw the diagram and you will get a general idea of what is to expect. So final latitude will be 6 degree minus 2 degree 20 minutes, which is 3 degree 40 minutes south. 3 degree 40 minutes south. Okay. So yeah. So 3 degree 40 minutes south, option number A. Okay. Question 8, option number A. Okay. 3 degree 40 minutes I have found. You have to select the closest option, which is 3 degree 50 minutes in the question. Okay. So this is how you do. Pay attention to the latitude. Okay, so when you enter the new hemisphere, the latitude should be south. So 3 degree 40 minutes south. Next, question number 9. Aircraft is at latitude 10 degree north and it is flying south. South, that means 180 degree direction at a speed of 444 kilometers per hour. After 3 hours, the latitude will be how much? So this question is similar to the previous question. The only thing here different is they have not given us distance information directly. They have given us the speed and time. If we know speed and time, it is easy or it is possible to find distance. Now distance will be equal to speed into time. Speed is 444 kilometers per hour. Time is 3 hours. So 444 into 3 is equal to 1332 kilometers. Convert this into nautical mile, divide it by 1.85, which is 720 nautical mile. Okay, let's plot the diagram. This is your Earth. There is an equator separating the hemispheres or dividing the Earth into hemispheres. Our initial location is 10 degree north. The direction of flight is south. We have to find new latitude. The distance is 720 nautical miles. Now great circle distance formula is difference between two latitudes in degree multiply by 60. Therefore 720 equals to Difference between two latitudes into 60. Difference between two latitudes equals to 720 divided by 60, which is equal to 12 degrees. Okay. Now it is highly probable that a new destination or new latitude falls in the southern hemisphere. So let's add, because your initial latitude is 10 degree north, right? And the difference between two latitudes is 12 degree. It is 12 degree. It is more than 10. So that is only possible when aircraft has crossed the equator and entered new hemisphere. Okay. So difference between the two latitudes equals to initial latitude plus final latitude. This is 10 degree and remaining 2 degree will be in the southern hemisphere. So this will be a final latitude. So 12 degree equals to 10 degree north plus new latitude. New latitude will be equal to 12 degree minus 10 degree north, which is 2 degree south. So new latitude is 2 degree south. Okay. So this is how you do this sum. Next. Question number 10. The circumference of the earth is approximately how much? The circumference of the earth is 21,600 nautical mile or 40,000 kilometers, or well, 21,600 into 1.15, that is 24,840 statute miles. So select any options which has either of these values. Okay, 21,600 nautical miles or 40,000 kilometers. Very simple question, but important question. It is often asked in Viva questions, your DGCS, CPL, ATPL exams as well. So remember this fact. With this question, we come to the end of this fruitful lecture. I'll see you in the next video lecture where I will be solving the next questions from this chapter. Till then, practice all these 10 questions. Watch other video lectures that I have uploaded on my channel, namely VOR ADF questions, payload questions, altimetry questions, etc. etc. I also request you all to like this video lecture, subscribe to this channel for more knowledge, and share this video with all your friends. All the best. See you next time.